Today in geometry, we're looking at section 2.6. We're going to start the geometric proofs. We're looking at segment and angle proofs. So let's talk about some theorems that we haven't discussed yet. We have the vertical angle theorem, which states if two angles are vertical, then they are congruent. We have the linear pair postulate, which says if two angles form a linear pair, then they are supplementary. We will be able to abbreviate this as LPP. A vertical angle theorem, we can abbreviate as VAT, V-A-T. We have the definition of right angle. An angle is a right angle if and only if it measures 90 degrees. And then we have right angle congruence theorem. If two or more angles are right, then they are congruent. Remember that a postulate is a geometric rule accepted without proof, and a theorem is a geometric rule which must be proved using previous postulates, properties, definitions, etc. So let's review some of the properties that we've talked about. The reflexive property of congruence. Remember, reflexive is like looking in a mirror. You get the exact same thing back. So what is congruent to the angle 4? That would be angle 4 is congruent to angle 4. The symmetric property of congruence. We need to fill in the if they give me the then, segment CD is congruent to segment DX. Remember that symmetric, they just traded places. So this would say segment DX is congruent to segment CD. Transitive property. If measure of angle 1 equals measure of angle 5, and what? And this should say equals, not congruent. Then the measure of angle 1 is equal to the measure of angle 7. This would say, and the measure of angle 5 is equal to the measure of angle 7. Then the first, angle 1, equals the last, angle 7. Definition of congruent segments. If MN equals AR, then what I can do, I can change them to segments and make them congruent. Segment MN is congruent to segment AR. And definition of congruent angles. If angle ABC is congruent to angle MNP, then again, I can change that and say the measure of angle ABC is equal to the measure of angle MNP. All right, so let's get into writing our first geometric proof. So given DE equals EF, right? And I'm going to go ahead and mark that in my picture that they gave to me. So DE and EF are equal, so they both get one tick mark. EF equals DF, so one tick mark. They want me to prove that segment DF is congruent to segment DE. Right? Remember, these are my statements. These are my reasons. I always start out with my very first statement, what they give to me. So they gave me DE was equal to EF. This is given. And they also told me that EF is equal to DF. This is also given. So now they want me to prove DF and DE together. So I need to get DE and DF in the same statement. I see DE, EF, then EF to DF. I can use the transitive property and say, therefore, DE, the very first one, is equal to the last one, DF. That is my transitive property of equality. And then remember that we can change from equals to congruent with the definition of congruent. So then I can say segment DE is congruent to segment DF, definition of congruence. And I'd like to see, have I proved what they asked me to prove? Almost. They asked for DF to be first, so I know that I can just trade places and make this say segment DF is congruent to segment DE by the symmetric property of congruence, since I have a congruent sign. That was our very first geometric proof. Not too bad, right? So let's look at another one. Given the measure of, given angle ABD is a right angle, measure of angle 1 is 42 degrees. So over here, I'm just going to put 42 degrees. Okay? Prove the measure of angle 2 equals 48. So again, here are my statements, here are my reasons. I will start out listing what they give me. So angle ABD is a right angle. Given. And they also told me measure of angle 1 equals 42 degrees, given. They told me since angle ABD is a right angle, that tells me that the measure of angle ABD is 90 degrees. How do I know that? Definition of right angle. I know that if I add these two together, angle 1 and angle 2 together, I get angle ABD. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABD. That is the angle addition postulate that tells me that. Now I already know the measure of angle 1 and the measure of angle ABD, so I'm going to substitute those in. So instead of measure of angle 1, I'm going to put 42 plus measure angle 2 equals, instead of measure of angle ABD, 90. This was substitution property. We substituted those values in. And now I can solve this to get the measure of angle 2 by itself. So then I get measure of angle 2 equals 48 degrees. My reason, what I did, I subtracted, right? So subtraction property of equality. My last statement, measure angle 2 equals 48 degrees, is exactly what they asked me to prove, so I know that I'm done. All right, let's look at another one. So here, given angle ABC is a linear pair, prove the solution for x. Okay, so start out what they give me, angle ABC, linear pair, given. Also over here in the picture, they told me that angle ABD is 9x and DBC is x plus 30. So I can put that in. So next I'm going to say measure angle ABD equals 9x. The measure of angle DBC equals 6 plus 30. Also given because they provided that in the picture. Now I need to talk about that I can add those two together and it's going to equal the great big one. So I can say that the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. Again, that's angle addition postulate. I know that the measure of angle ABD plus the measure of angle DBC is going to equal 180 degrees. How do I know that? Because they told me ABC was a linear pair, and that's my linear pair postulate, so LPP. I now have the ABD is 9x, so I'm going to substitute that in here. So I'm going to say, instead of ABD, I'm going to say 9x plus x plus 30 equals 180. Substitution. Now they want me to solve for x, so I have 9x plus x, so combine those, I get 10x plus 30 equals 180. My reason, combine like terms, CLT. I'm going to get x by itself, so move my 30 over, I get 10x equals 150. My reason, I subtracted, so subtract property of equality. And finally divide, so I get x equals 15, division property of equality. There was another geometric proof that we just did. All right, so let's go to the back and look at some more. So in the back, given segment XY is congruent to segment WX, so XY and WX, one tick mark. YZ is congruent to WX, so that also gets one tick mark. Right? Prove the solution for X. Again, these are statements, these are reasons. I need to start out with what they give me. They told me XY is congruent to WX. They told me WZ is congruent to WX. These are both givens. If I want to get X, Y, and YZ congruent to each other so that I can set them equal and solve for X, right now I can't use transitive property because the second one is not in the right order. XY to WX, I would need WX here, but I have that property that tells me I can trade places with these. So my next statement is going to just say WX is congruent to YZ by the symmetric property of congruence. Now I can do the transitive property and say the very first one, xy, is congruent to the very last one, yz, by the transitive property of congruence. If they're congruent, I know that they have to equal each other, so I can say xy equals yz. That's our definition of congruence. Now that I have that they are equal, I need to know what is xy. Well, I come over here in my picture, they tell me that xy is 3x minus 11, and yz is 14x minus 2. These are both givens, right, because they put them in the picture. So notice I didn't write them down in the proof until I needed them. So now I'm going to go back to number 5, and I'm going to substitute xy with 3x minus 11 equals substitute yz with 14x minus 2. My reason, substitution. I'm ready to solve this. To get all of my x's on the same side, I'm going to move my 14x over, so all of my x's on the left-hand side. So I end up with negative 11x minus 11 equals negative 2. This was subtraction, property of equality. Move my 11 over, so I get negative 11x equals 9. This was addition, property of equality. And finally divide, I get x equals negative 9/11, division, property of equality. Sorry, that was division, property of equality earlier. I've solved for x, so I've done what they've asked me to do. Great. Again, let's just do some reviews. Justify each statement by naming the property, postulate, definition, etc. 9 times x minus 3 equals 9x minus 27. They distributed. This is the distributive property. Number 2, if x equals 7, 7 equals y, then x equals y. So the first equals the last. That's the transitive property of equality. Number 3, if AB equals CD, then segment AB is congruent to segment CD. I changed from equals to congruent. That's the definition of congruent. Number 4, if angle A and angle B are complementary angles, then measure of angle A plus measure of angle B equals 90 degrees. That's the definition of complementary. And now let's complete the proof. They give me all of the reason or all of the statements. We just have to provide the reasons. So given measure of angle A equals measure of angle B. So number 1, given. Number 2, measure of angle B equals measure of angle C. They gave me that as well. It's also given. Measure of angle A equals measure of angle C. That's the transitive property, the very first, the very last. So transitive property of equality. Then they changed from equals to congruence. So that's definition of congruence. And then they traded places with the C and the A. So that's symmetric property of congruence. So that's it. That's day 1 of geometric proofs. Not too bad, right? We will practice a lot more of these.